Hi, let's talk about cardiac output. So cardiac output is the amount of blood that the heart pumps in a minute. And we will abbreviate it as CO. And two terms that you need to memorize is the formula for stroke volume, which is the end diastolic volume minus the end systolic volume, and the formula for cardiac output, which is equal to heart rate times stroke volume. So make sure that you are able to spell out what EDV and ESV stand for, so that you're clear on that. So stroke volume is equal to how much blood the ventricles pump with each beat, with each stroke of the heart. And the volume is the same for the right ventricle and the left ventricle. So let's say that the end diastolic volume, the maximum volume of blood in the heart at the end of rest, is equal to 135, and subtract from that the volume that's left in the heart at the end of systole, which is the ESV, the end systolic volume. So just plugging these numbers in, stroke volume is equal to 135 minus 74, and that gives us a volume of 61. 61 what? Mils per beat. So it's important that you keep the units straight. And that is stroke volume. A little bit messy, but you get the idea. Heart rate is beats per minute. So if we have, so we're going to use the formula at the top for calculating cardiac output. So cardiac output is equal to heart rate times stroke volume. So if we have, let's do this again, cardiac output now equals 80 beats per minute. So we'll write it in this form, 80 beats per 1 minute, times the stroke volume, which was, we'll use a figure above, which was 61 mils per every beat. So we're set up there, and then we can cancel the beats, and we're left with mils over minutes, and when we multiply those together, we get cardiac output equal to 4880. What are the units? Mils per minute. And I am assuming, and I will assume, that you can convert 4880 mils to liters. Do the unit conversion problem if you need to, but that would be equal to 4.88 liters per minute. But cardiac output is normally expressed in mils per minute. So again, at the bottom, a note to remember that both the right and left ventricles pump the same volume, but not the same pressure. Okay, the next slide is practice with the cardiac cycle. We left off with this picture similar to this in the previous lecture on the cardiac cycle. I found this one and I liked it, and I thought I would just throw it in here sort of as review. And what I like about it, the picture's a little bit fuzzy, so I don't like that, but I think you can read most of it. So there are a list of terms on the left here, and what you ought to be able to do, these are events or structures, is take each of those and plug them into the appropriate place on the cardiac cycle, on the figure on the right. So, a couple of things to note. At the very top of the panel is an ECG tracing. Pen is on the fritz. And the middle panel is pressure. And the bottom panel is volume. So 3 different things going on during the cardiac cycle. So for example, can you identify where atrial systole takes place? Well, one thing to note, on the ECG, you know that the P wave is the start of atrial depolarization, and it continues all the way across. Somewhere in the QRS it ends, so let's just say this portion here is equivalent or associated with atrial systole. That period. Okay, it's also associated down here, so maybe what would help work on this diagram is just to number these. You could do it this way, or you could just write in the boxes, but that might get kind of messy. So, if that was number 1 again, where would that correspond down here? Well, that region would also correspond to atrial systole. Next thing is semilunar valves open. So where do the semilunar valves open? You need to figure those things out. I'll give you a hint on this one. I would put number 2 in there. And since we are on the left side of the heart, you should be able to tell me which semilunar valve opens. Remember that we have 2 of them. We have the pulmonic and the aortic semilunar valve. So you might just go down through this list and see if you can identify each of these features. Let's jump to the bottom for a moment and just look at the volume, calculating the stroke volume. So you know that stroke volume is equal to what? N diastolic volume minus N systolic volume. So can you read those off of the figure on the right? Well, we're after volume, so we're going to be looking at the bottom picture. And N diastolic volume is the maximum volume in the heart at the end of diastole. So the ventricles start to contract with the QRS. So here is the maximum volume in the heart. And that's the EDV. And it looks like it's about 135 mils. And the minimum volume, or the amount of blood left in the heart at the end of systole, is the end systolic volume. So this would be the ESV. And it looks like it's about 65 mils. So there's your end diastolic and your end systolic, and you can calculate the stroke volume. So I would print out a couple, or maybe one, copy of this diagram and practice. So I would print and practice. Doing this. And calculating cardiac output or stroke volume. Okay, see you next time.